Okay, so more on how the previous alkene reaction occurred in just a second. But first I have to introduce you to a bit of new terminology. These terms are going to be nucleophile and electrophile. So to be very generic, nucleophiles and electrophiles describe the action of a molecule towards other molecules. You can break down this interaction graphically and in terms of electron flow. So nucleophiles are going to be characterized by a large amount of electrons, and we can just kind of give it a graphical term like this. So this is our electron or electron-dense molecule. So this is a molecule that's going to have a lot of electrons. So because of this excess, these nucleophiles are going to be very willing to give up their electrons, and they're going to give up their electrons in an action called a nucleophilic attack. And very generically, we can say nucleophiles attack. Nucleophiles are never attacked, they always attack something else. The question then becomes, well, what exactly are they attacking? Well, nucleophiles are always going to attack electrophiles. And so this nucleophile, or this E-, this very generic depiction, it would attack the electrophile. Well, the question then is why? Why is it trying to attack the electrophile? Well, electrophiles are characterized by a large deficit of electrons. So because of this deficit, they're really willing to accept electrons from wherever possible. And so we could say this deficit, we can just kind of characterize it by this positive charge. And we can say that this electrophile is really willing to accept electrons because it has this deficit. So electrophiles are really willing to accept electrons in this nucleophilic attack, this term that we used before called a nucleophilic attack. So we would always say that if nucleophiles always do the attacking, electrophiles are always attacked. So nucleophiles attack, electrophiles are attacked. And we can depict this attack and attacked relationship in a pictorial way with this arrow notation. So the arrow notation that we're going to use starts on the nucleophile and it's going to end on the electrophile. And we say that the arrow that we have just drawn always have two parts. It has a base and a head. And the electrons always begin their movement at the base of the arrow, and they always end their movement at the head of the arrow. So pictorially, what's happening is this nucleophile is attacking the electrophile. So pictorially, this is the beginning of the attack, and this is where the attack ends, which is on the electrophile. So nucleophile can be broken down into two terms. So that's going to be nucleo and phile. So nucleo is going to translate to nucleus or positive. Okay, and the phile is then going to be broken down into loving. So loving and phile. So phile, we say, can be broken down into loving. And so positive loving, you always love what you don't have. And so the nucleophiles would love to be around a positive charge. And so the way that they're going to be around a positive charge is if they do this attacking motion. Okay, so then we can do a very similar thing to the electrophile, which is that you can break down the electrophile into electro and phile. And so electro breaks down to electron, and phile is again loving. And so you always love what you don't have, and so the electrophile would love to be around some extra electrons. So it's going to be very electron loving. Okay, so the way that you can think of this is that because the electrophiles are very electron loving, they're really happy to be attacked by something that has a formal negative charge or a partial negative charge. Okay. So now that we have an idea about what nucleophiles and electrophiles are, we can use these terms to talk about specifics of how an alkene double bond can combine with a hydrogen halide, so the reaction up above. So before we move on to that, though, let me just give you a couple of examples of nucleophiles and electrophiles. So some examples of nucleophiles would be things that either have a formal negative or something that has partial negative or something with a high amount of electron density. So some examples that we could probably see for molecules that could act as nucleophiles could be like hydroxide ion. Hydroxide ion has a negative charge. It's pretty obvious that it could donate that electron density to something else. You could have, a halogen with a negative charge on it. So that iodine with a negative charge, you could have that attack something else with its high electron density. And so both of these guys are going to be negatively charged with a formal negative. But then we don't necessarily have to have that formal negative. We could also have something like, say, NH3. So this NH3 doesn't necessarily have a formal negative, and indeed it doesn't if you did the formal charge calculation. But nevertheless, that nitrogen's very electronegative, and it could still utilize those electrons on the lone pair to attack another electrophile. So we have two examples of negatively charged nucleophiles and one example of a neutral nucleophile. And just like with the nucleophiles, let's give some examples for the electrophiles. So electrophiles, or E, you can have like, say, an H+. So this H+ has a positive charge, and because it has a deficit of electrons, you'd say that this would be an electrophile, and it could be attacked. Another example would be, let's say, this carbon in the center. This carbon in the center has a positive charge, and again, this carbon doesn't have a very large electron density, and so because of that, it could be attacked by a nucleophile. And so just like before, we have two examples of formal positives for a molecule that could be attacked. And then let me give you another example of a molecule with a neutral charge. So this is BH3. This boron doesn't really have a formal positive, but the boron does have an empty orbital that could be attacked by a nucleophile. So the idea that you should take away is that nucleophiles are either negative or neutral, and nucleophiles always attack, and electrophiles can either be positive or neutral, and electrophiles are always attacked.